Hi, good morning, everyone. I see we have a couple quick responders this afternoon. So, as stated, we will be starting at 2 o'clock. Just to give, we'll start a couple minutes after 2, actually. We just want to give some people some time to log into the application. Some people are not familiar with Zoom itself, so they'll take some time to find the right buttons and places to go to actually access the webinar. So we'll give them a couple minutes and then get going. I hope everyone is doing well today. Enjoying the warm weather on that. It's fantastic that things are starting to warm up. I see someone's already getting familiar with the interface. So Nicholas gave me a little wave of the hand. Okay, everyone, I think that's about sufficient time to get people to log on and join us for the session. Hopefully no one's experiencing load shedding. I didn't hear anything on the news or on the app, so hopefully that may not be preventing people from actually accessing this webinar today. But on that note, we are going to get started, and I will begin. So good afternoon, ladies and gentlemen, and welcome to everyone attending our first webinar of the Unstoppable series that will span over the next few weeks, running every Thursday. My name is Yashin Naran. I am a modern applications engineer, predominantly focused on digital manufacturing using Autodesk software platforms such as Inventor, Fusion, and AutoCAD Electrical. Today, we'll be looking at design with Inventor nesting. The session topics for today, we will start off defining nesting and get an idea of what this process entails. I will then answer some general questions about Inventor nesting, where it can be found, who has access, and how can it be accessed. After this, we'll take a brief look at the nesting workflow and then highlight some key aspects of the application. This will then be followed by a demonstration of Inventor nesting. To end, we'll have a short Q&A session. First off, what is nesting? Nesting can be described as a common process that is used in manufacturing to lay out cutting patterns to minimize raw material wastage. It's a process followed in order to extract shaped components from a flat sheet of raw material. A great example of this would be sheet metal flat patterns or shape profiles that need to be organized and laid out onto a sheet of metal prior to being transferred to a cutting machine. So it is common knowledge that raw materials can be quite costly, and any material that is wasted results in a loss of profit. Hence why it is important that shapes are arranged in the most efficient way possible. However, finding the most efficient nesting pattern can be a very time-consuming and tedious task, especially if you do not have an application that allows you to nest with speed and precision. This, of course, is where the Inventor nesting comes into play. Before we dive into the operations of Inventor nesting, I would like to address some common questions that may arise later on. Where can Inventor nesting be found? Inventor nesting is one of the many applications that form part of Autodesk's product design and manufacturing collection. Just to name a few that are bundled into the collection, we have Inventor Professional, Inventor CAM, Fusion 360, AutoCAD, and AutoCAD Plant 3D. As it stands, the product design and manufacturing collection is quite comprehensive, and in short, it contains all the tools you'll need to design, simulate, and manufacture. In terms of who has access to Inventor nesting, any customer who purchases or has an existing subscription to a product design and manufacturing collection will have access to Inventor nesting, and of course, all the other included products. How does one then access Inventor nesting? Any customer with an existing or new subscription will be able to directly download the application from their Autodesk account by simply visiting the link accounts.autodesk.com. Sign in to your profile and download the Inventor nesting from your available products. Alternatively, Inventor nesting can be installed directly from the Autodesk desktop app. The desktop app is pre-installed with any Autodesk-based product, and it's where you can quickly reference your downloads and latest updates. So the Inventor nesting workflow can be broken down into three simple phases. The first phase would be creating your design or model as individual part files or grouping them into an overall assembly. These models can be created with Inventor by using the specialized sheet metal environment and the tools it has to offer. If the components are not your typical sheet metal parts, but rather something like wooden parts or profiles, the standard Inventor modeling tools can be used. These parts would of course need to have a flat profile and a unique thickness. The second phase is where the Inventor nesting comes into play. How this works is Inventor nesting will extract the shape profiles and flat patterns from your model. The required shapes are then analyzed by the program's nesting algorithm. This will automatically arrange, nest, and organize your shapes on a single sheet or across multiple sheets. Inventor nesting is intelligent enough to automatically match all the different part materials and thicknesses being used, and then align them onto the corresponding sheet. The last phase, cut. There are two options to get your nesting data out for manufacturing. The first is your nest can be quickly exported to a DXF that can be used with a cutting machine. Or alternatively, a 3D model can be generated and used in conjunction with Inventor CAM to simulate the cutting operation. Okay, so we are going to pause for a little bit and run a quick poll. And the question that I'll be asking you is, are you currently using a nesting application? Okay, and we have a couple options, yes, no, or would like to. So I'll give you guys a couple moments to fill out that poll. So if you're unfamiliar with Zoom, a little menu will appear, have little checkbox nodes next to your answer, and you can enter those results. Okay, so after running that poll, we have 2 people that are currently attending using a nesting application. I'd definitely be inquisitive as to what nesting application they are using. Hopefully it is Inventor nesting. It is a great application to use. Okay, moving on. So here are some of the key aspects to Inventor nesting. Inventor nesting is an add-in that runs directly inside of Inventor. This allows you to work seamlessly between your CAD and nesting environment through one user interface. You do not have to worry about importing and exporting data to 2 different applications. Inventor nesting supports multiple file formats, not just the native assembly and IPT formats. Non-native files can be used in conjunction with Inventor nesting, such as DXFs, DWG, and step files. However, note there are some considerations that may need to be accounted for. These files will need to have a planar face and contain 2D profiles. The nesting process is automated and requires minimal inputs and short setup time, as we'll soon see in the demo to follow. A nest can be exported as a DXF or 3D model for downstream manufacturing processes. Inventor CAM, another add-in for Inventor, can be used to perform machining simulations on your nested data, allowing you to generate toolpaths and NC code for your machining operations. Okay, so we are now going to head over to the demo, just giving you a brief overview of the nesting environment and how it works inside of Inventor. Okay, welcome to my Inventor workspace. Before we actually get into any nesting, I'd like to showcase what we are going to create nests of. So inside my Inventor, I do have a couple of predefined components. The first one is a curved slot. We then have a wedge as well as an L-bar. So all three of these components, take note, have a material applied to them, which is going to be steel, and they are each a thickness of 1.2 millimeters, I believe. The next two components we have is the star and straight slot. So these last two have a material assignment of copper and a thickness of 0.8 millimeters. And what we're going to do with all these components is take them through to the Inventor nesting environment, do a nesting study, and see what would be the most appropriate or best nesting pattern that will give us the most efficient gains. So one that's going to be the most cost effective. In order to do this, it's quite straightforward. The nesting environment runs directly inside of Inventor and can be accessed via a few methods. So the first method, what I'm going to use, is actually open up a new template file that comes standard when you install nesting utility. So that's going to be a standard millimeter nest, and of course you can go and then configure your own default templates, so you don't have to make manual adjustments and setups to your nesting process. Okay, so once my template is activated, you'll notice I'm directly inside the nesting environment. Currently it's blank, and of course we haven't started the process yet. In order to do so, I'm going to hit the sources button, and what this is going to allow me to do is actually extract information from the 5 part files that we saw previously. And over here, all I'm deciding is what information I'd like to include in my nest and what shaped profiles would I like to extract. So those are the 5 part files: the curve slot, L bar, star, straight slot, as well as the wedge. So what nesting utility is going to do at this stage, it's busy thinking, it's getting all the information, extracting it from our part files. You'll notice the little hourglass appear, so that information is still being processed. Over and above that, you'll notice a message appear on my screen. It's not an error message. This message is just indicating that the material assignments for the parts that I used do not match with the process library of nesting utility, and that information needs to be mapped. No worries, because that information will automatically be mapped once I confirm this little dialog box over here. So it will take a couple seconds to load. It seems like it's complete, and I can confirm that mapping information. So over here, what you'll get is a short display of all the information that nesting utility was able to extract from our part files, and you'll notice a little tick button, so that we're all successful. And then you have some general information. What were the files, the source files that we extracted information from? So you'll get the names of the IPTs. More importantly, you'll get the material name as well as the thickness of each of those components. So very quickly, the shape profiles have been extracted, and those are the profiles that we can then use to arrange and orientate onto our sheets of raw material. Now what you'll notice is the shape profiles are previewed on screen, and each of them are different colors. Okay, so you'll notice the curve slots, L bar, and wedge are a brownish color. This just indicates that those components can potentially be nested onto the same sheet, because of course the same thickness as well as the same material, whereas opposed to our 2 purple pieces over here, the star and the slot. Those of course are a different material. They're made out of copper and have a different thickness. Now at this point you can actually start the nesting process. I'd just like to go through some baseline configurations that can be made, or rather where these configurations can be made, and that would be by accessing your process library. So what your process library is essentially going to display, it's going to display all the common materials that you use as well as their thickness. So you have a look in my library. The 2 materials that I had assigned to my components have automatically been mapped as per that little message we saw earlier on. And what you can do at this stage is make some adjustments to the material. Okay, some standard properties, the material name, thickness, what category it resides in, the density, as well as the nesting color that is assigned to the material, which is quite nice. It just gives you a quick way to identify your different materials and the sizes. Over and above that, you'll notice just below the material you have the packaging. Okay, so this is quite important. The packaging is going to be the raw material that you're actually going to use to cut these shapes from. In this case, you can edit your packaging. I'm going to leave it at 2 meters by 2 meters, and within your packaging, what's very important is this cost field. So you can decide the cost for each sheet, and that will allow Nesting Utility to calculate or do cost estimations as to how much material you're wasting and what is that going to cost you. So you can of course create a more than one packaging, okay, for each material. For example, steel, 1.2 millimeter thickness. We don't just have one raw material size that can be used. We may have multiple. We may have a 1 by 1 meter sheet, 2 by 2, as well as a 3 by 3. So you can add all those additional packagings through that interface as default sheets to be used for your nesting study. So at this point, I'm not worried about making any adjustments. Just wanted to showcase some of the changes that you can make, and I'm going to simply select OK. So I'm satisfied with those inputs. What I want to do next is actually start generating and creating my nesting study and see how these shapes are going to be organized onto a sheet of material. In order to do that, I can simply create a new nesting study, and of course you can run more than one nesting study until you find the most efficient nesting pattern that's going to be the most cost efficient, as well as the one that's going to suit your manufacturing capabilities. So from this menu you can make some default changes to the name of the study. You can place a comment in, but more importantly we'd like to stipulate how many times we'd like to run this job. So how many instances of the shape profiles that have been extracted are we going to manufacture and create. In this case I'll have 10 pieces for each extracted shape. Over and above that you can define the stack size. So the stack size is just going to be what is your machining operation? Do you cut 3 pieces of material on top of each other? You can input that information there, and then it will be calculated into your nesting study as well as yield the desired calculations. Next up you have a little shapes tab, just general feedback of what's included in the nest, the material types that are being used, the thickness of the components, and the components themselves. After that you can decide what packaging you'd like to use. In this case we only have 2 pieces of packaging 2 and 3. That's going to be the 2 by 2 meter copper sheet of material and the 2 by 2 meter steel material sheet. And of course you can have more packaging loaded in there, so you do have the choice of configuring that. After that you can make some default changes into how your nesting environment is going to behave. So those will be your global parameters. The first option is defining the position of the nest. So how's it going to build in relation to your sheet? In this case our nesting shapes are going to be starting from the lower left hand corner of our sheet and then built up towards the top side of the sheet, and then you can change that all depending on your machining operation. So if you machine from the lower left hand corner of the sheet, you can align your nesting studies to align with your machining operations. Just below that we have some additional inputs in terms of how long is the nesting calculation going to take. Of course you may want to limit it if you are running hundreds of components or shape profiles at one time. You don't want it to take too long, but that however is generally not the case. The nesting study does run in a suitable fashion and a suitable time frame. Just below that you'll have something called the desired yield. So what is your goal? What are you trying to achieve? And over here we are trying to get a desired yield of 80%. So we'd like to utilize 80% of our material So once I'm satisfied with those inputs, I can select OK. And Inventor nesting utility is going to think a little bit. It's going to run its algorithm, and it's going to create our nests for us. So this doesn't take very long. As you can see, it's populated the nest, or the information for the nest, and then the nest itself. So you'll see those two nesting profiles display on my screen. So we have the first nest containing our steel components. Okay, so that's the L-bar, the wedge, and the curve slot, and they have been neatly stacked and orientated onto our sheet. So with each study you'll get some information. Okay, the efficiency, in this case we only used about 20%, 19% of the total sheet. The cost of that is 269 Rand. Okay, and in that case there's not going to be too much of a difference in terms of the cost, because we are only using one sheet, and one sheet costs 269 Rand. So over and above that you'll get the total nested cost. So how much of the material did you use? We used approximately 70 Rand of the total material. So we are wasting quite a bit over here. So this nesting study isn't quite efficient and effective. I would like to run another one. Let's just reference the one at the bottom very quickly. That's going to be our copper shape profiles that are going to be cut out, and those are stacked and nested on the 2x2 meter copper sheet of material, and then we have the similar information displayed at the top. Okay, so like I said, that's not quite an efficient nesting study that we just run. We can quickly run another one. So what I'm going to do is create another nesting study, same shape profiles that are being used. However, I'm going to increase the number of jobs that we'd like to run, so the number of instances of the shape profiles that we'd like to cut out, and of course that's going to fill up my raw material, or my sheet that we will be referencing. So the nesting study is still processing, and it's about 89% done. Just to touch on something else, is there is a good synergy between Inventor and the nesting environment, so there's some associativity. If I had to make any adjustments in the part files that were referenced in the nesting study, the nesting study will be able to adapt as those changes are made. Okay, so the nesting study is complete, and let's have a look at those results. So if I scroll down, you'll see my second nesting study has been populated, and this one's a little bit more comprehensive. So if you have a look, we've gone and populated the sheet with more shape profiles to be cut out, and it gives us a better desired yield. Okay, so close to our desired goal of using 80% of the raw material, and that's going to be a lot more cost effective and efficient to use, and we can decide to actually manufacture this. So let's have a look at the bottom. A little bit less efficient. We still have some space, so we could go and adjust our nesting study or create a new one and have the sheet populate with more components. Now in this instance I am satisfied with the sheet over here, which is going to be sheet 3. At this point what I can do is export this information to a DXF, where it can then be used to taken to the machine itself and used to cut out these components from the sheet. So this can be done very quickly, simply by selecting your sheet, running an export. When I run an export, it's going to ask me to define the name, and take note, it's going to be exported as a DXF file. So it's going to be sheet 3, and I'm going to save that quickly, and I will open it up in a couple seconds just so we can have a look at how that populates or is built. Okay, so I've referenced that sheet 3. I'm busy opening it up at the moment. I'm using DWG TrueView to do this, just because it opens up a lot quicker. You can of course open this up inside of AutoCAD, do some cleanups on the exported DXF file of our nesting pattern, and then process that onto your cutting machines, whether it be laser, water jet, etc. Okay, so it seems like it's loaded into my Autodesk tree view. If you have a look, I'll zoom out, and there we go. We have our DXF pattern that we've exported and have processed through the nesting environment directly from Inventor. Okay, well, alrighty, that concludes the demonstration portion of this webinar session. And what we're going to take a look at is opening up the floor for so any questions that anyone may have. So there is a chat box. Feel free to type out any questions that you have in relation to nesting utility, or even some pertaining to Inventor. In the meantime, while you may be processing some questions that you'd like to ask, I'm going to ask you guys a question. I'm going to run an additional poll. Okay, so this poll is in relation to Unstoppable series, and the question is, which up and coming Unstoppable webinar are you looking forward to seeing the most? And then we have the list of webinars that will be up and coming in the next couple of weeks. So we've got generative design, automation with Inventor, cloud collaboration with Fusion, and what's going to be quite an exciting one is machining made easy with Fusion. So there's a couple with automation for Inventor, a lot with automation with Inventor. About 60% of people attending have chosen that, which is great. Automation with Inventor has a host of capabilities. It uses iLogic technology and some rule-based design to achieve automated component creations and assemblies. Fantastic. So I'm just looking at the chat. There is a question from Shirag. Does all process happen locally on a cloud service? So the nesting utility is going to run locally. It doesn't need heavy reliance on processing resources. So it does process very quickly, but that does happen using local computer resources. Okay, so I see majority of the crowd like definitely see automation with Inventor. Just to when that was happening, I believe that's 2 weeks from now. It will be hosted on a Thursday. Take a look at that. I think you will thoroughly enjoy it. Okay, so I see there aren't many questions coming through. Okay, so hopefully that's make a little bit of a mic adjustment there. Okay, so I see there are not many questions coming through. That's okay. On that note, I'd like to thank everyone for once again attending this Unstoppable webinar session on Inventor nesting. And I hope everyone has a fantastic week further.